So we're actually going to be the first ones to use it in the Southwest Basin at Davidson River. So it's really big news for us. It's very exciting, and we can get into why. But it's a really cool tech, and it's going to really help us level things up at Davidson River for ongoing exploration.
All right, welcome back inside our proactive newsroom. And joining me now is Sean Hilliger. He's the Vice President of Exploration for Standard Uranium. And Sean, great to see you again. How are you?
Likewise, Steve, I'm doing well, thanks.
Good stuff. Good to have you along. In talking to you over the last couple of years, one thing I noticed about you is you're always interested in sort of new technology, and that's something that we're talking about today because you've have partnered up with Fleet Space Technologies to use their tech in mining. So maybe explain to us who this company is and what they do.
Yeah, absolutely, Steve. They're an Australian company. They've been doing this, using this technology around the world in mineral exploration for a while. They actually started out as an aerospace company, hence the name. So they have their own network of satellites that they're utilizing for this. And so this technology, this ambient noise tomography, is actually essentially a passive seismic technology. So it's been used for other types of mineral deposits like copper porphyries. It's seismic's a big thing in oil and gas as well. So what they're doing here is pretty interesting and applying this to hard rock geology now and actually bringing this tech into the Athabasca Basin and applying it to exploration for uranium deposits. So they've worked with companies like ISO Energy and Uranium Energy Corp over on the east side of the basin at the Rough Rider deposit and Hurricane deposits. So it's a pretty exciting new thing that's coming into the basin, and a lot of big players are jumping on this. So we're actually going to be the first ones to use it in the Southwest Basin at Davidson River. So it's really big news for us. It's very exciting, and we can get into why. But it's a really cool tech, and it's going to really help us level things up at Davidson River for ongoing exploration.
Yeah, so tell me, Sean, how does it work? What do you do with that? How does it aid in what you do?
Yeah, so what we do with it is actually set up an array or a grid of these what we call geodes. So they're essentially like a geophone type deal. So you dig a little hole at surface, put it in the ground and set them up, about 100 of them or more potentially in a grid fashion over your area of interest. And what they do is, like I said, it's kind of a passive seismic. So there's, noises and vibrations that come through the ground from nearby activity through lakes and things like that. So what it does is actually builds up a 3D velocity model. So as noise travels through the ground, it interacts with different types of rock and gives us a different signal depending on the rock type. So it can really help us identify where zones of alteration might be, where these structures that we're interested in. So like the conductors that we always talk about, Steve.
Yeah.
So it's really going to help us vector in to a discovery at Davidson by highlighting and building this 3D model that we can use in tandem with what we've already done, the drilling we've already done, and the geophysics we've already done. So it just adds another layer to really help us paint a clear picture of what's happening in the subsurface.
Sean, when I was researching them and was reading a bit more about the company and the work that they do, the one thing that kept coming back to was the speed and accuracy at to which the technology is. Can you sort of talk about that part of it?
That's right, Steve. So there's a few different companies that use this technology. Like I said, it's not really something new. Just this application in the Athabasca Basin for uranium is kind of the new part. So the thing that sets Fleet Space apart is, like I said, they have their own dedicated network of satellites that they control. So it's actually constantly uploading that data in real time using their satellite network. So it actually builds that 3D model I was talking about on the fly, essentially, so that you
Hmm.
can see that data coming in and building the model in real time, which is very cool, actually. So it takes only about a week to collect the data and build that model and get the results. So that's extremely fast for this type of geophysical survey. Normally, we run the survey, and then there's a lot of, post-processing and things like that. So there's a decent
Yeah.
amount of time you have to wait until you get your product, whereas this is essentially instantaneous.
So, Sean, when do you hope to get this into the field?
Yeah, right away. I mean, as soon as the ground thaws, like I said, we have to dig holes to deploy these geophones. So we're gonna get over there as soon as we can. We're
Okay.
starting with work immediately. We're meeting with the team. We've been meeting with them for several weeks now. designing the survey, getting our grids figured out where we want to go, really focusing this over our highest areas of interest at Davidson River. So we're really excited to get it deployed. That'll probably be in the springtime next year, but we're doing a lot of prep work and geological work in the meantime to make sure that we do this the best that we can and target where we want to target to go drilling right after.
Yeah, it's going to be super interesting for sure. Sean, very interesting and keeping on topic. Live long and prosper with this. So thanks very much.
Absolutely, Steve. Keep an eye out for more news as we move forward with this. It's like I said, really exciting to be the first ones in the Southwest Basin using this. So we think it's really gonna push us to the next level and towards discovery on Davidson River.
Absolutely. Sean Hilliker, the Vice President of Exploration for Standard Uranium.